Alright guys, so it turns out that if I'm not performing the biochemical test I love the biochemical test I'm performing. And today we're going to be doing the nitrate test. And the nitrate test is complex because it turns out that it's not like most of the other biochemical tests where you either have red or yellow, it's one color or another, and it's positive or it's negative. On this test, there's many ways to be positive, or at least two there is, and only one way to be negative. And so you have to pay attention to when a tube turns red, not just if a tube turns red. So let's go ahead and look at what we have here. These are our nitrate test tubes from the previous lab, and we're going to be adding the reagents that allow us to interpret those tubes. So the two reagents that we're going to be adding are nitrate 1, and that's sulfonilic acid, so an acid. And then the other one is nitrate 2, which is dimethyl alpha naphthalamine, which is an organic. And so nitrate 1 and nitrate 2 will actually interact with the compound nitrite. And if a bacterium converts nitrate into nitrite, that is, it's a reduction, then we're going to see that the nitrite will react with nitrate 1 and nitrate 2, and it's going to cause a red color change. So we're actually looking for that red color change after the addition of the two reagents. If we see it, we can immediately say that our test is positive. So let's actually start out with a tube here from your previous examples, and we're going to add about 7 drops of nitrate 1. Give that a little bit of a mix. And then we're going to go on and add the drops of nitrate 2. Okay, and again we just want to mix that. And we're looking to see if we see a red color change. And it's just going to take a few minutes for this reaction to occur. Aha, voila. So you can start to see the red color change. It's getting pink, it's going to get pinker, it's going to then eventually turn red. So this organism is going to be positive for reducing nitrate to nitrite. So it's positive for the nitrate test, or we could say it's positive for nitrate reductase, or we could say it's positive for nitratase. Those enzymes are those terms are used simultaneously for the enzymes. So nitrate reductase or nitratase. So we get to see that dark red color change. So this is one way to be positive, is by converting the nitrate to nitrite, and it stops there and reacts with your nitrate 1 and 2 reagents. So let's go ahead then and look at a reaction that can be positive the second way, which is if you add nitrate 1 and nitrate 2 and you see no color change, it could mean that the organism has reduced the nitrate to nitrite and then it's kept on reducing it to some other nitrogenous compound, maybe even nitrogen gas. Let's look at one where that's the case. In fact, this is Pseudomonas aeruginosa. So in this case, we're going to add nitrate 1. Mix that and go ahead and add nitrate 2. And we'll give this a mix. And we'll wait a second, make sure there's no reaction that we're missing. But we see no color change. So what this means is one of two things. It might mean that the organism has not reduced the nitrate, it hasn't converted it to nitrite, hasn't reduced it at all, and it lacks the enzyme nitratase, meaning that it's negative. But on the other hand, it took the nitrate to nitrite, and then it kept on reducing it all the way to other nitrogenous compounds. And so in order to find that out, we're going to add a metal, zinc, to cause the reduction to occur and see whether or not it's negative or whether it's positive by taking it to other nitrogenous compounds. So I'm just going to add a little bit of zinc. And we'll just stir that around. And now, zinc is an elemental metal. That means that it reacts very slowly. So let's let it sit for just a second here and watch for that reaction. But we see no color change. So this means that this organism is positive for nitrate reduction. But what it's done is it's taken nitrate to nitrite, and then it's reduced it all the way to further nitrogenous compounds. And in fact, in this case, it looks like it's reduced it all the way to nitrogen gas, because you can see the bubble in the durum tube. Okay, so let's look at an organism that's actually negative for this reaction. This is Streptococcus pneumoniae. So let's go ahead and add the nitrate 1 and 2. And again, give those some time to react. But again, we see nothing in this case, so we're at the crossroads one more time where we know that it might either be negative for nitrate reduction, or it could be positive via the second mechanism of taking it beyond nitrite. So we're going to add zinc, and zinc is what tells us that, and we remember that if it turns pink, pink after zinc means that it's negative. So let's add some zinc. And once again, we need to give that zinc some time to react. So while we're waiting, let me show you a little more about the nitrate test. This is a hard one to understand, so sometimes a picture helps. Remember that in this test, the enzyme that we're searching for is the enzyme that converts nitrate to nitrite. That's a reduction. And the enzyme that does that is often called nitratase. As I mentioned earlier, it's also sometimes called nitrate reductase. So we're looking to see if an organism has that enzyme and it can reduce the nitrate to nitrite. Well, we're going to see later this is a really important part of the nitrogen cycle. So many microbes that can do this help in nitrogen cycling. But one way that this can get done is that the nitrate can get converted to nitrite, and it stops there. So we could say that there are two ways to be positive. Let me label the positive ways here in pink. One way to be positive is to convert nitrate to nitrite and stop right there. If that's the case, when you add those two reagents, nitrate 1 and nitrate 2, those two compounds, the acid and the organic, interact with nitrite, and that creates a red color. So if you turn red after the addition of nitrate 1 and nitrate 2, that's the first way to be positive, right? By turning red after nitrate 1 and nitrate 2. The second way to be positive, though, is in organisms that convert nitrate to nitrite, but they keep on going, and they take it all the way to some other reduced form of nitrogen, maybe even nitrogen gas, right? And so in that case, there would be no nitrite there to react with nitrate 1 and nitrate 2, ever. So this would be, labeled in pink, the second way to be positive. Now there's only one way to be negative. The only way to be negative is to leave it as nitrate, right? So one way to be negative, two ways to be positive. Let's look at what would happen then if we had anything other than the first way to be positive, right? In that first way, you add the nitrate 1, nitrate 2, and everything turns red. But if you add nitrate 1 and nitrate 2 and there's no color change at all, then you know that there's two possibilities. One, the organism is negative. Two, the organism further reduced the nitrate to other nitrogenous compounds. So you have to determine which way it is then. So after adding nitrate 1 and 2 and seeing no color change, your next step is to add zinc. So with the addition of the metal zinc, zinc will convert nitrate to nitrite. Thus, if you have a negative organism, the zinc will reduce the nitrate to nitrite, and then it will react with nitrate 1 and nitrate 2, and that'll give a red color. Thus, pink after zinc means negative. However, if you add the zinc and the organism has converted the nitrogen to other nitrogenous compounds, then you're going to see nothing, because other nitrogenous compounds plus zinc equals no color change. Cool. So that helps me understand the nitrate test. I hope it helps you guys too. Oh, let's check our two. Hey, yay, pink after zinc.